Today's lesson is section 2.2. We're starting to look at polynomial functions. So first we'll determine the end behavior of a polynomial function. And end behavior, what that is basically what direction it's going to the left and what direction we're going to the right, whether up or down. Okay? So we notate this as x approaches, that's that arrow, as x approaches infinity, what happens to f of x? Does it approach infinity or negative infinity? As x approaches negative infinity, what happens to the y's? What does f of x approach? And a polynomial for us is it has any degree, okay, possible. So a sub n times x to the n, okay, n could be 1 or 2 or 3 or 4 or anything, okay, and it will decrease in degrees as we move to the right. So as far as end behavior is concerned, if we're moving up to the left, then as x approaches negative infinity, so as we're going to the left, f of x approaches infinity. It's going up. If we're moving up to the right, then as x approaches infinity, then f of x approaches infinity. If we're going down to the left, as x approaches negative infinity, f of x is approaching negative infinity. And down to the right, as x approaches infinity, f of x is approaching negative infinity. We could also have the case, let's go back and point out, if the degree is even, then that's when we end up with these cases that's up, up, or down, down, okay? If the degree is odd, then we have the case where we could go down, up, or up, down. So looking at this one, we can determine immediately, since the degree is odd, then that means we're going up, down, or down, up. Now something else that you could see back here if a sub n, so if the number in front of the x to a degree is positive, then we're going down, up. So basically we're moving up overall. If the number in front is negative, then we're moving down to the right. Back here, if the number in front is positive, then we're up, up. If the number in front is negative, then we're down, down. So here I can already say that it's going to be down, up. We're going to be moving up to the right because the number in front of x to the fifth is positive and we have an odd degree. Okay, so a is positive and n is odd, so that means we're moving down, up. So we can say that as x approaches negative infinity, then we're going to be moving down. So f of x approaches negative infinity. As x approaches infinity, as it's going to the right, then f of x is going up, so approaching infinity. For example 2, We don't have to multiply this all out because we've got a degree here that's 3 and we know that there's a degree here that's 1. So that means that we have a negative, or our degree in is 4, 3 plus 1, which means we have an even degree. And A, the number in front, is negative. Okay? So since we have an even degree, then we were either up, up, or down, down. But since it's negative, then we have to be down, down. So as x approaches negative infinity, then f of x approaches negative infinity. As x approaches infinity, f of x approaches negative infinity. So as we go to the left, we're going down. As we go to the right, we're going down. Next, we're going to look at zeros and multiplicity. So zeros are still where we're crossing the x-axis. It's the x-intercept. Just another way of saying x-intercept is the zeros. We could also call these the roots or the real solution. So several names for x-intercepts. Okay. A couple of things here. If a polynomial function has a factor x minus c, then c is a zero of that function. It is a solution to the function. Notice the opposite, okay? If the factor is x minus c, then c is the zero, which makes sense, because if you have x minus 3 equals 0, then your solution would be x equals positive 3. And it's of multiplicity k. So, depending on the degree of this, so if it was a 2, then the multiplicity would be 2. If there was a 3 here, the multiplicity would be 3. If it's just 1, the multiplicity is 1. Now, there's important things about the multiplicity, okay? If the multiplicity is odd, then the graph crosses at C. If the multiplicity is even, then it just touches. Okay, so that's going to become important for us. Turning points are just somewhere where it was opening down and it starts opening up. So that's a turning point. Or it could be where we were going up and then started going down, or something like that. Okay, so those are turning points. Determine the zeros of this function. And by the way, got a little mistake here. This is supposed to be a 2. Okay. So, determine the zeros of this function. To determine the zeros, we need to factor it. And luckily, we can factor this one pretty easily, even though it's x cubed, because we can factor it by grouping. So, this is a nice case here. So, the first part, we can factor out an x squared, and we're left with x minus 5. And the second part, we can factor out 16, a negative 16, and we're left with x minus 5. Okay? And so that would give us factored x squared minus 16 times x minus 5. Well, we know that x squared minus 16 is a difference of squares, so that has to factor to be x plus 4 times x minus 4. So we've got these three factors here. And so to find the zeros, we would just set each of them equal to 0. So our zeros would be negative 4, 4, and 5. Okay. Next says determine the zeros and their multiplicities. This one's already factored for us, so that's nice. So first we have that 8x equals 0. We have just what's on the inside. X minus 1 equals 0, and x plus 3 equals 0. Okay, we don't need to do it 2 times or 3 times. So here x is 0, x is 1, and x is negative 3. So the multiplicity for 0 would just be 1. The multiplicity for 1 is 2. And the multiplicity for negative 3 is 3. We're just looking at the degrees. And so we could also determine here, since it's a multiplicity of 1, since it's odd, then we must cross. This one's even, so it touches. And this one's odd, so it crosses. So what effect do the multiplicities of the zeros have on the graph? So here we've got a graph where we've got zeros that are, we've got negative 3, we've got 0, and we've got 1. Okay, so what's what here? Well, x equals 0 is a multiplicity of 1. That's odd, so that means we cross. And you can see from the graph, in fact, we do cross. For x equals negative 3, that has a multiplicity of 1. And again, it crosses. And last, x equals 1 has a multiplicity of 1. And we can see that it crosses. Okay, what about this one? So first we've got x equals 0. That has a multiplicity of 1. And we can see it right there. It crosses. We've got x minus 1. That's a 0 of 1. Its multiplicity is 2. That's even. And so you can see right here at x equals 1, it only touches. So that's what we mean by touch. And then x plus 3, a factor of x plus 3, the 0 would be negative 3. That has a multiplicity of 1. And we can see over here that the multiplicity is odd and it crosses. One more. Here we've got a x equals 0. It has a multiplicity of 1 and it crosses. X equals 1 has a multiplicity of 1 and it crosses. X equals negative 3 has a multiplicity of 2 and it touches. Okay, so moving a little bit further, identify the zeros of the function and whether there is a cross point or a touch point at each 0. Okay, so same thing, only without a picture. So here we've got negative 3x squared. That's just x equals 0. It has a multiplicity of 2, and so that means it touches. X minus 4 its 0 is negative 4. It has a multiplicity of 1, and so that means it crosses because it has an odd multiplicity. And last, we have a 0 of 7. It has a multiplicity of 3, and since that's even, it will cross. Okay. And we can see the picture right there. So, for example 7, give the maximum number of turning points. Well, we know from our theorem back there that if we have a degree, a degree of 3, then we have at most 2 turning points. And we can see that from the graph. By the way, yeah, so it's where we've got a maximum or a minimum, or relative maximum or minimum, not in between, by the way. Okay, so for the last two examples, what can we do to actually sketch a polynomial function? Well, we have to go through these steps. So the first one is, what is the end behavior? Okay, well, we can determine the end behavior by, first of all, the degree. So we have a 2 here, a 1 here, and a 1 here. So the degree is 4. And that's even. And then the number out front, A, is just 1. So positive A. Okay, so what does that mean? Since our degree is even, it's either up, up, or down, down. Since we're positive out front, then it's got to be up, up. So that means as x approaches negative infinity, then f of x approaches infinity, and as x approaches positive infinity, f of x approaches positive infinity. And I'm going to go over here on my graph and just going to make some little notes that we're going to be going up, up. Next, how many turns are there? Okay, well, the degree is 4 again. So that means that there are at most 3 turning points. We don't know exactly. There could be 2, there could be 1, but there are at most 3. How many intercepts are there? Okay, well, there's 1, 2, 3 factors, so that means there's 3 intercepts. Do they cross or touch? Okay, well, the first intercept is 1. Its multiplicity is 2, which is even, so it touches. The second one is negative 3. Its multiplicity is 1, so it crosses. And at x equals 4, its multiplicity is 1, so it crosses. Okay, so we know we've got some points at x equals 1, x equals negative 3, and x equals 4. And that these two cross. Well, what does that mean? If we're coming from positive infinity here to the left, then we're going to have to be going down there. If we're going back up to positive infinity to the right, we're going to have to be going up there. So could this touch here? No, it's going to have to touch underneath here. So it's going to do something like this. Okay, so let's see, what else can we find here? We can find we've got quite a bit of information. We can find a y-intercept. That's going to be helpful. So let's do that. Let's go back to our steps. What does it say exactly to do? So we found the multiplicity and the end directions, and let's see, we can test for symmetry. Yeah. And we can plot some points. I'm gonna do the y-intercept here. So the y-intercept is going to be where x is 0. So we've got -1 squared, that's 1, times 3 times -4, so -12. So we have a y-intercept at 0, -12. Notice my y-axis here goes by tens, okay? So it's going to be somewhere like that. And another thing is to find some points in between, okay? So let's find a point in between here and here, okay? It's got to be down here somewhere. So let's just try f of -2. Well, that'll be -2 minus 1, that's -3 squared. -2 plus 3, that's 1. And -2 minus 4, that's -6. Gives us -54. So, 1, 2, 3, 4, 5. Oh, nope, it's -2. So, about right there. Let's see, what else can we find? Let's find, we've got a good picture of what's going on over here so far. Let's find a point between 1 and 4, okay? So let's just find f of 3. So 3 minus 1 is 2, 2 squared is 4. 3 plus 3 is 6. 3 minus 4 is -1, -24. So at 3, we're -24. And so that gives us a pretty good base to go on here to draw our picture. So we're touching, we're going through that point, we've got a turn there, and we're going up. And then touching, coming down, going back up. So it's definitely not exact, but it's a very good sketch that gives us an idea of what this polynomial looks like. Okay, so for the next one, let's just do the same thing. So the end behavior here, we've got a degree of 1 and 2, so we have an odd degree because the degree is 3, and a negative a. Okay, so odd degree means we're going down, up, or up, down. Since it's a negative a, then we're going down to the right, so up, down. So as x approaches negative infinity, f of x approaches infinity. Okay, we're going up to the left, down to the right. As x approaches infinity, f of x approaches negative infinity. How many turns are there? Well, the degree is 3, so there's at most 2 turns. How many intercepts are there? Well, 1, 2. Do they cross or touch? Well, we've got an intercept at x equals -1. Since its multiplicity is 1, which is odd, then it's going to cross. We've got a 0 at x equals 3. Since its multiplicity is 2 or even, it's going to touch. So we've got -1 and 3 here. So if we're crossing and we're coming from the up here, then it's going to have to cross like that. And then if we're going down here, then we wouldn't be able to go that way because it would end the wrong direction, so we're going down again there. What else should we find? Let's find the y-intercept. So let x be 0. We've got y equals negative. 0 plus 1 is 1. 0 minus 3 is -3. We're going to square that. And so we've got -1 times 9, which is -9. So we have a y-intercept at -9. Notice our y-axis is in 5s. So it's going to be about right there. And you could find some more in here. I don't think there is one thing I put on here wrong, because at 3 we touch, don't we? So let's see. If we're coming from this direction and going down to the right, then we're going to have to touch like that. Okay, sorry about that. And so I think we've got enough information to really be able to graph here, because we're coming down this way, going up, and back down. We really didn't need a whole lot in between this time. And so that's the end of our introduction to polynomials.